Hi everyone, bonjour. The IB Crocodile is here. Welcome to my IB channel. Today I'm going to solve this question here, Physics Standard Level, Paper 1, November 2022, number 14. So, a ray of light enters from air into a water droplet of radius r at point S. S is a vertical distance h from the center of the droplet, and then the droplet has a refractive index n, and the angle of refraction is theta here as shown in the figure. So since we see refraction and refractive index, so obviously we are going to apply Snell's law. So there are two versions of Snell's law. The first version is n1 over n2 is equal to sine theta 2. I mean, in some booklets they say sine theta 2, but I prefer sine theta r over sine theta I, where theta r is the angle of refraction and theta I is the angle of incidence. And most likely we are going to use this formula here. The other version of Snell's law, for your information, n1 over n2 is equal to c2 over c1, where c2 is the speed of light in the second medium and c1 is the speed of light in the first medium. But here in this question here, there is no mention about the speeds, so we're gonna focus on the sign, the angles. Now, n1 is the refractive index of air, since light enters from air, right? And n of air is approximately equal n of vacuum. In IB we don't differentiate between them, and then we're gonna just assume that it is 1. So n1 of air is 1, and then n2 is the refractive index of the second medium. Here he call it n, so I'm just call it n or write it as n. And then sine theta r, here he call it theta, just the angle of refraction, and then over sine theta I, where theta I is the angle of incidence. It's very important note that we know that the angle of refraction or the angle of incidence are measured from the normal, between the normal, which is not drawn here in this question. So what I would do first, I would sketch the normal to the surface from the point, right? So let me okay, I'm going just to draw the tangent here. So to see it clearly, the normal is going to be that line here, because here is the radius. So we know the radius from circle geometry. The radius is always perpendicular to the tangent at the point of contact, or the point of tangency. Okay, so now since this is the incident ray, so the angle between this ray and the normal is going to be theta I, right? And this side here is parallel to this side here, and you can see like F letter, right? So we can say this angle here, so these two parallel lines here, and this is F, we call it corresponding angles. So this angle here is also theta I, right? And then theta, which is the angle of refraction, with what this is what we are looking for here, between the normal and the reflected ray, which makes sense. Okay, so now let's rearrange the formula now of Snell's law to get sine theta, the subject. So sine theta is going to be 1 times sine theta I over n. 1 times sine, just cross multiplication, over n. Now sine theta I, now from this triangle here, so theta I, okay, if I just complete this triangle here, so I can, see more like clearly. So this will be a right angle triangle, right? And sine is opposite over hypotenuse. So sine theta I, you agree with me, it will be this side here divided by that side there. So h over r, opposite over hypotenuse. So I can replace, sorry. So I can replace sine theta I by h over r and then I still have n at the denominator here. So the answer is C. So H over NR. Okay. So just simple application of Snell's law. The bottom line here to remember that the angle of reflection or the angle of incidence are measured between the normal and the rays themselves. Thanks for watching, and see you in further questions to be solved together.